Alright, let's talk about the parts of a parabola when we consider them as conic sections. First thing I want to do is help you to realize that a parabola can be vertical or horizontal. So a parabola has this sort of shape. A vertical parabola could open upward like this, or it could open downward like this. A horizontal parabola could open left like that, or it could open right like that. Okay, so those are our two choices, and each of these has the same parts, so let's describe those now. Okay, so every parabola has a vertex. It's a point, so I'll label this the vertex. And then depending on which direction the parabola opens, so let's assume the parabola we're going to draw here opens upward, it has a focus that is above the vertex. So a parabola always wraps around its focus. Okay? So here's our focus. Alright, and furthermore, opposite the focus on the other side of the vertex, there's something called a directrix. The distance from the focus to the vertex is the same as the distance from the vertex to the directrix. So these two distances are the same. The directrix is a line. In this case, it's a horizontal line. Okay, we'll talk more about that in a minute. So this is called the directrix. Kind of a funny word. Alright, finally, there's one other distance. Let's take an example here. Let me move this word down just a little bit. Let's say that this distance here is 1 and 1. Okay? You might give that a name. I don't know what you might call it. Maybe F. F is 1 in this case. That distance up and down from the vertex is 1. Then you can measure the width of the parabola. It's 4 times this distance. So I need to go 2 units in each direction to get a total of 4. So 1, 2, 1, 2. And then I have 2 more points on the parabola. So the parabola starts at the vertex, wraps around the focus, going through these 2 points. Let's try that again. So this distance here is 4 times as much as this distance. So in this case, it's 4. And that is called the focal diameter. Diameter, kind of like a distance. The focal diameter is the distance through the focus across the parabola. So in this case, it's 4. So that's the relationship between the focus, the vertex, and the focal diameter. Okay, so let's try another one now. I know this seems like a lot all at once, but you'll see how easy it is in just a moment. Okay, here's an example. I've set up what's going to be a horizontal parabola. This is the vertex, this is the focus. So the distance across has to be 4 times this distance. So what if I tell you that the distance across, in this case, let me draw the parabola. Looks something like this. It opens to the left. Here's the directrix. What if I tell you the distance across, in this case, the focal diameter, is 3. I could then ask, what is this distance here? And of course that distance would be the same as this distance. Well, if you have to multiply this by 4 to get 3, then you'd have to divide 3 by 4 to get this. So this distance would be 3/4. 3 divided by 4. Okay, so we've got our vertex. Let's label these one more time. This is the vertex in this case. This is the focus. And this is the directrix. So those are the parts of a parabola and how they relate. The distance across through the focus is 3. Then the distance here is 1/4 of that. Or if you take this distance and multiply it by 4, you get this distance.